talk about congruent triangles, so first we have to talk about congruent polygons. And so if you have congruent polygons, that means that all sides and they're matching, like between the two polygons, matching sides are the same length and matching angles are the same measure. So all the sides and angles are congruent that are corresponding. Corresponding are, that looks like XIME, doesn't it?
I was about to ask you, did that say same?
Yeah, I don't know. I don't know what I did there, but it's SA. But as I was looking at it from the side, it looked like SI. So, okay, so the sides and the vertices are in the same position. So if we look at these two triangles here, like you can see the bottom one rotated. And the way we know that A and P are supposed to be in the same position is because of the way the triangles are named. The letters that go in the same order represent the congruent parts. So A would be congruent to P, B is congruent to Q, and C is congruent to R. Same order, so same position. And then that lets me know which angles are supposed to be congruent, and then the sides between them will match up too. So as you can see between A and B, that'll be the same side as between P and Q. So the polygons are congruent if and only if their corresponding parts are congruent. So in order for ABC to be congruent to PQR, A has to be congruent to P, B to Q, C to R, and then AB to PQ, BC to QR, and AC to PQ. So the matching sides and matching angles have to be the same size. Does that make sense? If we were going to label these with proper geometric symbols as opposed to these colors that I use. So I have two, let's say just two triangles, and we're going to pretend they're congruent even though they're not, because I didn't draw them properly. But and I'm going to say ABC is congruent to PQR. To show that the angles are congruent, you put the same number of little half loops in them. So A would be the same as P, B would be the same as Q, and C the same as R. So that shows that the angles are congruent. And then to show sides, we put the same number of slash marks. So AB and PQ, BC and QR, and then AC and PR. So those are the proper geometric symbols for labeling the congruent parts. Questions on that?
What does it mean when there's like 3 lines in one line, but there's no third line to match it? Like the 3 streaks on one side? Because I don't remember, I think it was in one of the problems yesterday, there was like only one line with 3 dashes in it, and I didn't know what it was congruent.
It may not have been congruent to anything. It may have been just showing you that that side was a different length than the other ones.
Okay.
Does that make sense? So like I could have, say that triangle there, and I could take that same length, but change the angle. And those could be the same, but then these aren't, so I might say that's 3. But this one I won't know. You know what I mean? To show you that those aren't congruent.
Yeah, that makes sense.
Go ahead and erase that so people looking at it later don't go, what is it? Alright, so, oh, darn it. Okay, so we want to identify all the congruent and corresponding parts and then write the congruent statement about the 2 whole triangles. Not on. Okay, so we look at the marks and we can see that angle J is congruent to angle T. Angle P is congruent to angle V. And L is congruent to S. Okay. And then looking at the sides lines, we have JP and TV. PL and VS. What's a V? And then JL and TS. I'm not writing well for this afternoon. What time is it? Okay, so we have all the corresponding parts. Questions about that at all? Or is that part okay? Now to make our congruent statement, we're going to talk about the whole triangle. And for the first triangle, it doesn't matter what order the letters are in. We can put them in any order we want. So I can call this JPL, LPJ, JLP, PJL, like whatever. So what order do you want those to go in? Nobody cares? Okay. So I'm going to call them JPL. Whatever order I put these in, the matching letters have to go in the same order though. Since J matches with T, T has to go first. And then P, so V, and then L, so X. So the first one won't matter, but the second one you have to put it in the same order so that when you're done, the corresponding angles are in the same position. So not too bad. DF is itself, so obviously it's not going to be marked because it is only one line, so it's only congruent to itself anyway. When we talk about these angles, that one piece. I'm going to make it like that so we can kind of see it as bigger. If this angle is the same as that one and this one is the same as this one, I can either number these or I can talk about them in the 3 letters. So if I number these 1, 2, 3, 4 like that up there, I don't have a number inside. I can say angle 1 is congruent to angle 2, which is an equivalent statement to angle EDF is congruent to angle GDF. And I could also say FDE and FDG as long as the D is in the center, because I'm talking about the angle that has D as the vertex. So these are the same thing as long as I label the picture. And then I could say angle 3 is congruent to angle 4, which is the same thing as angle FDG. Oops. EFB is congruent to GFE. So when you have a picture like that, you can either label them with numbers or you can use the letters. But if you use numbers, you have to label it so I know what you're talking about. And then angle E and angle G are congruent. And then DE is congruent to DG. GF is congruent to EF. And DF is congruent to itself. So if I say DEF, triangle DEF, let's go in the same order, so DG. Right, because step 1, label congruent parts if necessary. let's get to so if I look at this, it's kind of hard to tell on just the video here, but you can, if you look at your paper, you can see that this has 2 lines and this has 1. So I'm just gonna draw them on there like that. Okay, and it's really kind of hard to read. So this angle is 108. That angle is 48. 48. And then this is a y, and that's 2x minus y. So far, okay? So ABC is congruent to FDE, which means that we already have C and E marked as congruent and B and D marked as congruent. That leaves A and F. So A and F would be congruent. So we can mark that if we need to. And we want to find the value of X and Y. Well, I have 2x minus y, and I have plain old y. So I want to find y first. And angle D is the same as angle B. So since angle D is congruent to angle B, y is 48 degrees. So that's number 4 done. Okay. And so this is 48 degrees. And angle C and E are the same, so this one is 108 degrees. So far, okay? So we can figure out how much is this from that 180 degrees that the triangle always is. So we take that 180 minus 108 and minus 48 and 24 left over. So F is 24 degrees. So that means that 2x minus y is 24 degrees. So far, okay? So 2x minus y is 24. And y is 48. Plug that in there. Really? Like that, and then I add 48 to both sides. So 2x is 72. Subtract, or divide by 2. And there's x. So I found y first to find x. And that's what I meant when I said, like, sometimes they don't always come in the best order for solving them. So look at the picture and solve the one that makes the most sense first. This angles in a triangle theorem, it's like the third angle theorem. So if you have 2 angles in one triangle are congruent to 2 angles in another triangle, then that makes the third angles congruent. So if I have 2 triangles, and this angle is congruent to that one, this angle is congruent to that one, well, since they add up to 180, they'll be the same, that third angle will be the same, because if these two are the same, then that one has to be the same, sort of forces it. Does that make sense? Now, this is true with angles, but not true with sides. If 2 sides of one triangle are congruent to 2 sides of another triangle, the third side is not necessarily congruent. It depends on, because the side length would depend on angles. So theorem is only good for angles. So that would make these would have to be congruent. Now we can use that to solve problems. So if I have angle NPQ, so NPQ, that's that angle, is congruent to RST, so that's this angle. And NPQ is 40. Then I want to find SRT. I want to find that angle right there. Well, this one's 40. This is 40. That makes this one 40. And these two are congruent, the 40 and the 90, the 40 and the 90. That makes these two congruent. So these are both going to be 50 to add up to 180. So SRT is 50. Make sense? That 40 is kind of hard to see. Same properties as we had before, but now with triangles. So reflexive property, ABC is congruent to ABC, same as itself. Symmetric property, ABC is congruent to PQR, then PQR is congruent to ABC. That's the flip around equal sign thing that we have. And then transitive property, if you remember, we have that middle guy situation that matches the and thing. If you take that out, you get the ends smashed together. So we take PQR out and we get ABC is congruent to XYZ. So same as before, just with triangles instead of angles or segments. Or, you know, numbers.